Okay, guys, here we are. Next section. This is the worst chapter. Let me tell you this. This is the worst chapter. After this, the topics, if we do any more, when we do any more, whatever, will be much more fun than this and a little bit less stressful than this particular chapter. So, this is the next section on, now we're going to solve equations that have these rational expressions in them. So if we had this particular addition problem, we would get the common denominator, change both fractions to the common denominator, and then add them together. Now, that's what we would have to do to add them, right? But what if, instead of just being an expression, I made this into an equation? So notice now I put equal 1. So now we have an equation to solve. So what do you think you would do here? Now, I'm sure you're not thinking at all about what you should do there, and that's okay. But let me ask you this. What would you do if I gave you that equation with fractions? What you should be saying is, I know, Mrs. A, I would get rid of the fractions first, okay? And if that's what you said, you're right on the money. So the question is, how do we get rid of the fractions? Well, we're going to multiply by the least common denominator. So in this case, particularly here, I would multiply both sides of the equation by 12. Because why do I choose 12? Because now when I multiply, 3 will cancel in the 12 and leave a 4, and 4 times 2 would be 8x. 12 times 3/4 is 9, and then I get 12, and then that's a very easy equation to solve. So, now, let's go back to this and use the same strategy. Up here, we picked 12 to multiply by because it was the least common denominator. So down here, the best way to solve is multiply by the LCD. So now the question becomes, and this is why we practice this, what is the least common denominator? Remember now, this is prime. So I can't factor x minus 5, so it becomes a prime factor in itself. X is not a factor here, 5 is not. It's this whole quantity. So that's prime, and I have an x, which means my least common denominator needs each factor that I see the most number of times it appears. So I'm going to need an x, and I'm going to need an x minus 5. So that is what I'm going to do to both sides of the equation. So I'm going to come down here and multiply this side by x times x minus 5, and this side times x minus 5. Whatever you do to one side, you have to do to the other. And I'll tell you, one of the most common mistakes is kids forget that they have to multiply over there. So, now this means I have to multiply this whole side by that. So when I multiply this times this, the x minus 5s are going to become 1, right? Those are going to sort of, not be there anymore. They're going to turn into 1. So I'm just going to get 8x there. Nice, okay? But then I have to multiply this by that term. Now in this case, this x and this x are going to become 1. So I'm still going to be left with 3 times x minus 5. This 3 times the x minus 5. And then over here on the right, I'm just going to have 1 times x minus 5, which is x squared minus 5x. So this looks like something I can do. We can handle this. So now I'm going to just simplify everything out here. And I see an x squared, so what does that tell me? I have to move everything to one side and get 0, and I always like keeping the squared term positive. So I'm going to move all this over there. So this is 11x. So when it moves over here, it's going to become negative. So I'll have x squared minus 16x. And when the 15 moves over, it becomes positive. So now I'm hoping this can be factored. So this is positive, which means I have to have the same signs. Since that's negative, they're both going to be negative, and I'm going to have 15 and 1. And that tells me x is either 15 or 1. Now you know that some of these methodologies produce these extraneous solutions. So what you're going to have to do is go back to the original equation and say, do either of these answers, 15 or 1, cause a problem with the initial equation? Most of the time, if it causes a problem, it's because it's going to make one of the denominators 0. So that's not happening here. 15 or 1, neither one of those makes them 0, so those are both going to be legitimate solutions. Yes, yes, okay, that's good. All right, so let's go on and try another one. Oh boy. So there's my equation now. I got an equation. So I would like to get rid of, we're not going to put them over a common denominator. We're going to get rid of the denominators by multiplying by the LCD. So this is x minus 3, that's x plus 3, this is x minus 3 times x plus 3. So nicely, the LCD here is going to be x plus 3 times x minus 3. Now, again, I'm not going to put these over the least common denominator. I am going to multiply both sides of the, equation by x plus 3, x minus 3. X plus 3, x minus 3. Okay? So when I multiply this times this, the x minus 3's merge, become 1, and I have 6 times x plus 3 left. Okay? On this side, when I multiply this by this first fraction, this whole denominator and that whole denominator can pair up and become 1. So I just get 8x squared. Okay, come on. All right, when I multiply this by this fraction, the x plus 3's are going to merge and become 1. And I'm going to have, now watch, I got that subtraction sign, negative 4x times x minus 3. And so now I just have to solve this. So let's go through and simplify. 6x plus 18 equals 8x squared minus 4x squared plus 12. All right. And again, I'm getting quadratics. I'm going to keep them over there. 8x squared minus 4x squared is 4x squared. So those are there. If I move the 6x over, it becomes negative. If I move the 18 over, it becomes negative, and I get negative 6. Now, I'm going to make my life easier, and I am going to factor out a 2 first. And then let's see if I can get this factored. All right, hope I'm not doing something wrong here. If I made a mistake somewhere, you guys are gonna let me know about it, aren't you? By email or letting me know. 8x squared minus 4 times x minus 3. Okay, took a 2 out. Okay, I don't think that's factorable. So if that's not factorable, now I can just divide both sides by 2 and get this. And then what would I have to do? If I can't factor it, what do I have to do? Use the quadratic formula. Opposite of b, plus or minus, square root of b squared minus 4 times a times c, all over 2a is 4. So what are we going to get here then? We're going to get 3 plus or minus radical what? That would be 9. And 2 negatives are going to make a positive. That's going to be plus 24 all over 4. So 3 plus or minus radical 33 all over 4. Should have probably worked this problem out before I did the video, but that's good. I mean, because I want you to understand that maybe not all of them are going to be factored, but I feel like maybe I made a mistake, but if I did, you'll tell me in one of the Zoom sessions, right? Okay. All right, so do we have another one? All right, do you want to try one more? Actually, I think there's 2 more. So this one is a good example because this cannot be factored and this cannot be factored, which means my LCD is going to be 2x plus 5 times 11x plus 8. And I'm going to multiply that to both sides of the equation. Okay, now over here, this will join with that and become 1, and I'll get 11x plus 8. And over here, this and this merge to become 1, and I have x times 2x plus 5. So I'll have 11x plus 8 equals 2x squared plus 5x. Let's get everything to the right. 2x squared. This becomes negative 11, so that's going to be minus 6x. And when the 8 moves over, it's going to be minus 8. Again, I'm going to divide both sides of the equation by 2. At least this one will be factorable now. And I'm going to get x and x minus 4 plus 1, which tells me x is 4 or negative 1. Now, I got to check my answers though. And 4 and negative 1 aren't going to make either of those denominators 0, so we're good. Okay? So that's that one. One more. Bear with me. You can go pause it and get something to eat if you want or whatever, but I'm going to move on. Okay, now in this one, we need to remember that that 3 is like 3 over 1. So I know that you're going to want to try to tell me that the LCD is just x minus 4. But remember, x is not a factor of that, so we also need our x there. So I'm going to multiply both sides by x times x minus 4. All right. So now this side has 2 terms. So when I do that, when I multiply this by the first fraction, the x's are going to form 1, and I'm going to have 10 times x minus 4. When I multiply by that, there isn't anything in the denominator to merge and make a 1, so I'm going to have 3 times x minus 4 left there. And then on the right-hand side, this and this will merge to become 1, and I'm going to have x times x plus 9. Okay? So let's go simplify this out. Watch, this is 3x squared. Now I have an x squared on both sides, but I want my square term to be positive, so I'm going to move this over here and subtract it out, so that'll be 2x squared. 10x and negative 12x is negative 2x, but when I move this over, it's going to become negative, so that's going to give me negative 11x. And then I have my minus 40. Okay, now I can't divide both sides by 2 here. I don't want to because I'd get 11 halves there and then I won't be able to factor it. So I'm just going to try to factor this as is. Oh boy, should have probably worked on this sooner. Okay, 10 and 4. Don't see that working. 8 and 5. Yes. If I put an 8 here and a 5 there, I'll get my 16x from here and my 5x from there, and I can get 11. So that's going to have to be negative and that's going to have to be positive. Okay? So what does that tell me my solutions are? What makes this factor equal to 0? Negative 5 halves, and this one is positive 8. Okay, let's go back and make sure neither of those is going to give us a 0 denominator. Nope, 8 will be fine, that'll be 8, that'll be 4. Negative 5 halves, no, that's not going to cause an issue, so we're good to go. So there's my solutions, negative 5 halves and 8. All right, guys, so there's going to be an assignment on solving some of these rational equations. Take your time and show the work. Now, this whole virus is getting a little frightening. I don't know if I'm going to be coming down to school anymore to make these. I will be making videos, but they might be a little less techy. I might be doing them at home with the whiteboard. We'll see how things are going. My children don't really want me going out and coming down to school, but we'll see how things go. So for right now, we're almost getting to the end of chapter 8. I only have one more section to show you, and we can wrap this ugly chapter up, and then we'll get into some more fun topics, you know, to end the year out, okay? I hope you're doing well. I hope your folks are well. If you have grandparents alive, FaceTime them, call them, talk to them, you know, whatever you can do so that they're not feeling too lonely. All right, see you soon.